Welcome. Let's solve this problem on the pumps. So we have this problem. A liquid with specific gravity of 1.26 is being pumped in a pipeline from A to B. Okay. Now there is a pipeline from A to B. The liquid is pumped. Means the pump is used, right? At A, the pipe diameter is 600 millimeters and pressure is 300 kilopascal. At B, the pipe diameter is 300 and the pressure is 330 kilopascal. So it is not a constant diameter pipe. The diameter is varying from A to B, and also point B is 1 meter lower than A. Point B is 1 meter lower than A, means the height of B is lower than A. So let's draw this. We have something like this. Okay, now here is the center line of this pipe. Let us assume it to be the center line of the pipe. This is point A, this is point B, right? Now let's write the details. Given data, diameter of A is 600 mm, means 0.6 meter. Diameter at B is 300 mm, means 0.3 meters. Now the pressure at A is equal to, how much is the pressure at A? At A the pressure is 300 kilopascal, 300 kPa, and pressure at B is 330 kilopascal. Okay, now point B is 1 meter lower than A. Okay, now the difference between, let me draw the datum line. If I draw the datum line passing through B, okay, this is the datum line. Okay, assume it to be the straight line. This is the datum line. Now B is lower than A by 1 meter. Okay, now we can find the datum head. ZB is equal to 0 because the datum is passing through B. Okay, we assume that, and datum at A is 1 meter, right? Because A is above datum by 1 meter. Okay, now if the pump puts 16 kilowatt, okay, kilowatt means energy, right? The energy, E for energy, P for pump, is equal to 16 kW, right? Now the first thing is compute the flow rate in liters per second. Okay, now the flow rate is denoted by discharge Q, right? So let's apply, to solve these problems we have to apply energy equation. Okay, let's apply energy equation between A and B. What we get, energy head at A plus head by the pump HP is equal to energy at B. This is equation first. Okay, now energy at A is equal to PA by rho G plus VA square divided by 2G plus ZA. Now pressure at A is 300 kilopascal, 300 kilopascal. Now ZA is 1 meter. Now VA we don't know. We have to find the discharge through this pipe whose diameter is changing. Now because this is only one pipe, it is a continuous pipe, it means discharge through all the points, okay, from A to B is same. Let the discharge be Q, then we know Q is equal to cross-sectional area A multiplied by V, velocity. What does that mean? Velocity is equal to Q divided by A. Now VA is equal to Q divided by AA, means AA means cross-sectional area at A, right? Now cross-sectional area at AA is pi by 4 d square. Diameter at A is 0.6 square, right? Diameter at A is 0.6 square. How much is it? 0.2826 meter square, okay? So the velocity at A is Q divided by 0.2826, right? So we can write at A Q divided by 0.2826, right? And square. Let me erase this. This is going to be right. So how much is the energy at A? This rho is the density, right? Density of fluid. Now density, a liquid with a specific gravity of 1.26, okay? So we know density of any fluid rho is specific gravity G multiplied by density of water, which is 1.26, and the density of water is 1000 kg per meter cube. So this is going to be 1260 kg per meter cube, okay? So how much is the density? Meter cube, right? Okay, before I continue, I want to let you know that don't worry about writing. I will provide the notes of this problem in the description, okay, or in the comments. You can download the notes in the PDF format of all my lectures, so don't worry about notes, just try to understand. And G is 9.81, which is acceleration due to gravity. So we can write EA is equal to 300 kilopascal. Now kilo means 10 power 3, right? Pascal divided by density is 1260 multiplied by acceleration due to gravity is 9.81 plus. Now this we can write this as Q square divided by 2G multiplied by 0.2826 square plus 1, right? So energy at A is, how much is this? Now if you solve this, it is going to be 24.27 plus, now if you solve this, 2 multiplied by G is 9.81 multiplied by 0.2826 square, 1 divided by all of this, you are going to get 0.6382 Q square plus 1. And now 1 plus 24.27 is 25.27, right? This is the energy at A. Now let me erase this. Now energy at B. Energy at B is equal to PB divided by rho G plus, basically it is energy head. Okay, we are writing the energy in terms of the energy heads, plus VB square by 2G plus ZB, right? Now PB is how much? 330 kilopascal, 330 kPa. Now VB, we can write it as, okay, let me solve it later. ZB is 0, right? So this term will cut because it's 0. Now VB, now because V is equal to Q divided by A, what does that mean? VB is equal to Q divided by area of cross-section area at B, right? Now cross-section area at B is how much? Pi by 4, diameter at B square. How much is it? 0.3, right? Let me show you. See, the diameter is 0.3 square. So let me calculate how much is it going to be. 0.07065. 0.07065 meter square. Okay, and we again have this density. Let me write it here. Density is 1260 kg per meter cube, right? So we can write here VB square is going to be Q divided by 0.07065, right? So VB square is Q divided by this, all of this whole square, right? So let me write this. It is going to be Q divided by 0.07065 whole square, right? Now rho is the 1260, so let me write EB is equal to 330 kilo means 10 power 3 Pascal, right? Divided by 1260 multiplied by G is 9.81 plus, let me write it like this, Q square divided by 2 multiplied by G. G is 9.81 multiplied by this square, 0.07065 square. Okay, now when you solve all of this, EB, now 330 multiplied by this, all of this, now this term is going to be 26.7. okay, all of this. So let me erase this. It is going to be 26.7, and when you solve this like this, let me erase this Q square here. I will put 1 here multiplied by Q square, right? Now when you solve all of this, it is going to be 10.2. all right, so I can write 10.2 in place of all of this, approximately 10.2. okay, because we round off the things, this Q square is going to be plus 10.2 Q square. okay, now here we get the energy at B. okay, we get the energy at A, energy at B. Now HP. Now HP, you see, we can calculate it like this. We know energy of pump is equal to m dot G HP. okay, energy supplied by the pump is mass flow rate due to the pump, m dot G acceleration due to gravity, HP is head by the pump, because we have to find HP. So now again we need to find the flow rate, right? Let me show here. We want to find the compute the flow rate. It means find Q, right? Q is a flow rate. Now here's m dot. We are going to convert m dot into Q, okay? That is mass flow rate into the volumetric flow rate, because that's, here it is volumetric flow rate, here it is volumetric flow rate. So for the symmetry, this will give us the volumetric flow rate too. So we are going to convert it into the volumetric flow rate. Now we know m dot is rho Q, okay? M dot is density times the volumetric flow rate is m dot GHP, okay? So how much is HP? It is EP divided by rho QG, okay? Now energy by the pump is how much? EP divided by rho QG. Energy by the pump is 16 kilowatt, right? Kilo, 16 kilo means 10 power 3 divided by rho, density is 1260, multiplied by, let me write like this, multiplied by 9.81 multiplied by 1 upon Q, right? So how much is HP? When you calculate, when you simplify this, you are going to get HP to be, this is going to be 1.3 multiplied by 1 upon Q, okay? So HP is 1.3 divided by Q, right? I can write Q here. This is the same thing. So let me erase all of this. Again, the notes, the PDF notes of this lecture you will find in the description, so don't worry about that, just try to understand. Okay, here we go. Now we have the HP too. Now when you put all these EB, EA, HP in equation first, what you get? Now EA is 25.27 plus 0.6382 Q plus HP is 1.3 divided by Q. Energy at B is 26.7 plus 10.2 Q square, okay? Now okay, here is 0.6382 Q square, okay? Now let me get the Q terms at one side and the constant terms on the other side. So we are going to get 0.6382 Q square minus 10.2 Q square plus 1.3 divided by Q is equal to 26.7 minus 25.27, right? Here we can get Q square to be common here and here. So what we get? 0.6382 minus 10.2 plus 1.3 divided by Q. Now 26.25 is it is 1.43, right? When we subtract these two. Now this, when we swallow, it is going to be minus 9.562 Q square plus 1.3 divided by Q is equal to 1.43. okay, now is it quadratic equation or it is a cubic equation? Now see, when you get this Q on this side, it is going to be Q multiplied by Q square, which is Q, right? So this is a cubic equation, and the solution, when we solve this cubic equation, the positive real number will be the value of Q. Okay, let me use a calculator. We can find the value of Q to be, okay, I solve the Q. We find Q is equal to 0.418 meter cube per second. So that's it. I find the flow rate to be 0.418 meter cube per second. This is approximately, okay, and that's it. Okay, so let me erase all of this, or just leave it there. No, let me erase it. Let me use this. Okay, so we found the discharge. Now let's find the other things. Now B is as compute the head added by the pump. Head added by the pump means HP, right? Head added by the pump. This HP. Now HP is 1.3 divided by Q. So HP is going to be 1.3 divided by how much is Q? 0.418, and it's approximately going to be 3 meters. Okay. So we find the head by the pump is HP is equal to 3 meters approximately, and compute the horsepower input if the pump has an efficiency of 80%. Now horsepower input, I will show you the formula of the horsepower input, and I think this formula is not really important. Okay, this is not asked too much. What is more asked is this, the energy equation, okay, the Bernoulli equation. They are very important. And so let's just write horsepower is specific gravity G multiplied by a volumetric flow rate Q multiplied by head by the pump HP multiplied by 1000 divided by 102 multiplied by neta efficiency multiplied by 0.746. Okay, this is the formula. Now G is how much? 1.26 multiplied by Q is how much? 0.418 multiplied by horsepower is how much? 3 multiplied by 1000 divided by 102 multiplied by neta. Efficiency is how much? 80%, right? Now how much is 80%? 80% means 80 divided by 100. This is 0.8. Okay, this is 0.8 multiplied by 0.746. Now when you solve this, okay, you are going to get horsepower to be 26.8 HP approximately. So we get horsepower approximately 26.9 HP. So we solved all of these problems A, B and C, and the coming lectures we are going to solve more problems on pumps and turbines and other fluid mechanics problems. Okay, and if you want to download the notes of this video lecture, they are in the description. You can download, okay, the PDF, okay, or in the comments somewhere. And yes, if you have any problem, please contact me. I will solve the problem for you. And for any other tutorial services from me, you can contact me for the tutorials too. And that's it. See you in the next class of fluid mechanics. Thank you.